So guys, in this training, we will be discussing about Zscaler services. What are the important services? That is Zscaler Internet Access and Private Access. A lot of content I have already created on this, right? But live training is live training, right? It gives you opportunity to ask your doubts and get the clarity, right? So here we will start with Zscaler Internet Access Service first, right? And then we will start with Zscaler Private Access. So I'll try to keep 10 to 12 classes of ZIA and 8 to 9 classes of ZPA. In totality, we will have 20 classes, right? Here, apart from Zscaler, because it's a SASE technology, right? Earlier, SD-WAN was not part of it as part of the SASE framework, but now Gartner has included SASE as part of, SD-WAN as part of the SASE. So we have to also touch upon SD-WAN because without SD-WAN, SASE framework is incomplete. Okay. So now Zscaler without SD-WAN is SSE solution, right? That is Secure Service Edge. So SASE is your framework, that is Secure Access Service Edge, which is a combination of SD-WAN and SSE. Okay. So SD-WAN, we all know that it is used to do the load balancing on multiple underlays and you know uh, take care of your application aware routing, auto recovery of the links, right? uh, Keep track of the metrics. For that we use SD-WAN. SSE, we use to guys, I take doubts at last. Please don't raise your hands right now, or you can just paste your doubts in the chat. SSE, we use it for security posture, for your internet bound traffic, and for your SaaS bound traffic. Okay. So Zscaler has two services, majorly ZIA and ZPA. So ZIA stands for Zscaler Internet Access, which is going to secure your internet and SaaS based traffic, right? On the other hand, the ZPA is going to secure your private traffic, right? So if I will show you the architecture, how it is going to look like, just a minute. So we have two services from Zscaler. Okay. One is Zscaler Internet Access, another one is Zscaler Private Access. So from any branch location, you have two types of traffic. One is your private traffic, another is your public traffic. Let's take an example. This is my branch location. This is my data center. Let's forget about Zscaler, right? Let's go back to the initial days when we were having MPLS. So we used to have MPLS cloud, right? So all these branches are connected with MPLS cloud, and we have, let's take an example, another branch. Now these branches are connected. So MPLS, we all know it is a private connectivity link, right? Shared with certain organizations, right? So if I want to reach my private applications, I will be using this link and I will be landing upon my data center where my all the workloads are available. All my applications, they are inside my data center. This is used to be earlier architecture, right? So we were coming from branches and we were going towards the data center. And we also used to call this architecture as hub and spoke. But now what is happening? Things are changing. Now we have more SaaS based applications, right? So earlier your internet traffic was also backhauling from the DC. So internet traffic used to come to the data center from the branches. And from here it used to backhaul towards the internet. So earlier customers were only buying internet circuits on data centers, right? So every branch is sending internet traffic towards the data center. And from there it used to go over the internet. We also used to call it backhauling. So initially, if you do the comparison, the percentage of traffic, 80% traffic used to be your private traffic. 80% used to be private traffic, your private application or enterprise applications. 20% of traffic used to be internet bound traffic. This was the use case earlier. Now the story is other way around, right? Now it is 80% internet traffic and 20% private traffic. Reason. So the very first reason is SaaS applications, adoption of SaaS apps. What is SaaS application? Software as a service. Earlier, we used to buy the licenses. We used to spin up the servers in the data center. And this is how we used to use the application, enterprise applications, be it Microsoft Exchange, your Dropbox, or any other ERP solution, right? Whatever we have, Salesforce and all. We used to build the servers in the data center, right? And this is how we were using those applications. But now everything is SaaS, software as a service. Classic example, today we all are connected through Teams. So I'm not using Teams in my data center. The server is not with me. So Team server is with the Microsoft data center, and we all got connected with the help of the internet. So now internet has become the new connectivity for enterprises, right? And the adoption of SaaS application has increased the internet traffic in any enterprise network from 20% to 80%. So these days, 80% traffic is internet bound traffic. It is public. Now, this public is having further bifurcation. First, your SaaS applications. Second, your normal internet applications, YouTube, Facebook, WhatsApp, right? So SaaS apps are different: Salesforce, Microsoft O365, SharePoint, Dropbox, right? These are SaaS apps. Internet apps, your normal internet bound traffic. Then comes your private traffic, which is almost 20% now. That is your private applications which you are using, right? So now if I will go back with the ordinary architecture where I was doing backhauling of my internet traffic, it will not make any sense. It will bring latency. Just imagine that I have 100 branches, B1, B2, B3, and similarly I have 100 branches. If they all will backhaul their internet traffic towards data center, that how much latency I'm going to get, right? So backhauling internet bound traffic on data center is not a good architecture as per the modern design, right? I cannot break out my internet traffic from here. It will include a lot of latency in my traffic flow, right? Because now if I want to, let's take an example. How do we communicate these days in office as well, right? We use Teams. Although my colleague is sitting next to me, but I'll initiate Teams call. Now the Teams call, although my colleague is sitting just next to me, will make outbound connection with the Teams server, which is there in Singapore. Right now, we don't have any server in India. So the call request will go to the Teams server that is in Singapore, right? So you both will be connected to that Singapore, and just imagine that you are doing backhauling. So first your traffic is coming from the branch location to the data center, and from data center it is going to the Singapore. How much latency are going to introduce, right? So to solve this problem, there was emerging demand for local internet breakout. So this concept came into the picture that you have to give local internet breakout to these branches. They should go directly over internet. They should not send their internet bound traffic on data center. They should go direct. Now, when you are directly going over internet, right, we all know that internet is not that safe. There are a lot of vulnerable servers available, malwares available. You need some sort of filtering, right? So one option is like that on every branch you can have firewall. Now firewall will be a cost. If you have 100 branches, are you going to install 100 firewalls? It will overshoot your budget, right? Because earlier you were having normal Cisco router and you were using MPLS. It was secure. So your entire security stack used to be on data center, right? So all the bulky firewalls and IPS, everything, your bulky security stack used to be on data center. But now things have changed, right? We are giving local internet breakout to the branches. And when you are giving local internet breakout to the branches, you need a mechanism through which you can do the deep packet inspection. You can provide cybersecurity to your users. You can safeguard them by connecting to the, by preventing their connections to the malicious websites, right? How you're going to achieve that? So Zscaler came into the picture, and Zscaler gave the solution to the market that you need a cost-effective solution that is cloud delivered. So Zscaler says that, you know, installing 100 firewalls on branches is not going to solve your problem. Instead, what we can do, you have your branches, take one SD-WAN router to handle your multiple ISPs, and forward your traffic from these branches towards me with the help of IPsec tunnel, GRE tunnel, right, or ZCC, whatever is the best traffic forwarding method you feel like, whosoever is the network architect, they will take that call and forward that traffic towards me. I will do the inspection for you, and I'll break out your traffic from my location, from my data centers. So traffic will be generated from the branches towards the internet, right? It will hit your routers. Router will forward it over the tunnels towards the Zscaler data centers, and Zscaler will provide you the security, right? So these nodes where the traffic is going to land, We also call them Zen nodes, Zscaler enforcement nodes. These Zen nodes will ensure that your traffic gets inspected and it is going to break out over the internet after deep inspection, wherever it is going over the internet towards any SaaS application or towards public application, wherever it is going, it will go until unless deep inspection has been performed by the Zscaler. Now, in this case, natting will be performed by Zscaler. So all these branches, these users, when they will be going over internet, they will be taking IP of Zscaler because NAT will be done in Zscaler cloud. So this will take care of your internet and SaaS based traffic. This service, which provides protection for internet and SaaS based traffic, is known as Zscaler Internet Access, ZIA. Okay. Similarly, you will have another cloud to safeguard your private traffic. Let's take an example branches. We know that with the help of SD-WAN, we can directly go to the data center, right? So how your SASE architecture looks like. So SASE means Secure Access Service Edge. Secure Access Service Edge. That is the combination of SD-WAN and SSE. So SD-WAN is software defined wide area network technology which will help you to do link load balancing, right? Application aware routing.
सर मैं एक सवाल पूछ सकता हूँ? हेलो
Chetan, I'll give you the doubt session. I mean, raise your doubts in doubt session. Okay. Let me just explain and then I'll give you option to ask the doubts. Okay. So SD-WAN is link load balancing, app aware routing, and your SLA based link selection, right? And other things also we can get out of SD-WAN. Similarly, SSE will help you to get firewall as a service, cloud access secure broker, that is CASB, data leak protection, DLP. It will also help you to achieve ZTNA, zero trust network access. Again, it's a framework under which a lot of things we have to focus upon. Network microsegmentation is one of the ZTNA principle, right? We should not be having flat networks and all that. Then you also have CASB is Cloud Access Secure Broker, DLP, Firewall as a Service, ZTNA, and then your Secure Web Gateway, proxy-based solutions, right? All these features you get from SSE. SSE is also known as Secure Service Edge. Earlier, back in 2020, 2021, we used to call it SASE as Secure Access Service Edge. But later on, Gartner included SD-WAN as part of it. It's a framework. So later on, Gartner included SD-WAN as part of the SASE framework. So it became SD-WAN plus SSE. So initially, Zscaler was not single OEM SASE solution because they were only offering this part, only these features. They were not able to provide SD-WAN, but now they have also introduced their SD-WAN solution, that is Zscaler SD-WAN. So initially in between, they introduced so many solutions as interim solutions, branch connectors, right? So many things they tried doing it, but it didn't work. Finally, we have got the box from the Zscaler, that is Zscaler SD-WAN. Because we need to understand there is one term, single OEM SASE solution, right? So Palo Alto is one of them. Palo Alto is having their SD-WAN as well as SSE. Then we have Cisco. Then we have Zscaler now, right? These are single OEM SASE solutions because, you know, from operation standpoint, if any customer is using Fortinet as SD-WAN and Zscaler for SSE, then a lot of challenges they face in terms of coordination, troubleshooting the issues, and all that stuff, which we are going to see in this training, right? So I will be integrating SD-WAN with Zscaler services. So you will see that when you are doing troubleshooting, you need to do it on SD-WAN as well as on Zscaler, both sides, to isolate the problem, right? So this is your SASE. Now, Zscaler private access, if we try to understand, so far we understood that ZIA is able to give us security against the public traffic. But how do we connect to our private applications if something is there in my data center or something is there in my AWS cloud or Azure cloud? How do I connect with those resources securely if I'm working from home, right? There comes Zscaler private access into the picture, ZPA. So we have one application which we call it ZCC, Zscaler Client Connector. That application helps to build tunnel, right? And here we call these data centers as brokers, right? And in our data centers and public clouds, we install app connectors, which helps us to facilitate the connection between the client and the server. Right now, you won't be able to understand these things. App connector, client connector, these are new terms for you. Throughout this training module, you will understand everything. That's why it has been designed in a way that first we will start with ZIA. We will cover all the use cases, industry use cases of ZIA, whatever production use cases we have. Once we are done with this, then we will kick off ZPA so that you can understand how ZPA works. Okay. Now in this training, what else we are going to cover? We will be covering OKTA integration as part of SAML. This we will be using for authentication. We are going to cover Splunk integration, right? We will also cover app connectors deployment in AWS as well as in private data center. So app connector deployment in AWS and ESXi, your private data center. And we will also cover Fortinet SD-WAN along with ZIA and ZPA. Because these two technologies, they are delivered through cloud. So you need to have a mechanism to forward your traffic towards these cloud because they are not going to receive until unless you are not going to forward, right? So these are cloud-based services, right? So we need to forward our traffic towards them. For countries like China, Dubai, where compliance issues are there, so we do have physical solutions, physical private boxes available, but those boxes are costly from Zscaler. So we will discuss about them, private service edges. Okay. So now I'll open up myself for doubts. So whatever doubts you have, raise your hand and I'll call out your name and then you can ask your doubt. And then we'll continue from here. Yeah, Siddesh, please go ahead.
Sir, how SSE architecture would be, sir? How it will be differentiated?